All right. So we want to look at a random digit table and how you can read a random digit table. And sometimes you're assigned to do it. But before we even get there, what is randomness? Randomness, we imagine like if you flip a coin a bunch of times, that it would be pretty equal 50-50. But if it alternates heads, tails, heads, tails, heads, tails, heads, tails, is that random? No, that's actually structured and deliberate. When you have a random sequence, there's going to be groups and clumps and stuff like that. If you actually look at the digits of pi, 3.141592653 dot 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 dot. Okay, you knowing this digit gives you no ability to predict what digit's going to come next. Knowing that this is a 4 doesn't help you know that this is a 1. Knowing this is a 1 doesn't help you know that this is going to be a 5. They are there is mathematical reasons why these digits need to be the way they are, but they are, for all intents and purposes, random. Okay, random is when there is no structure. There is no you're not deliberate or putting any choice into why you're choosing what you're choosing next. Okay, humans fail at being random. Okay, I'll demonstrate some of those in class soon, if I haven't already, depending on when you're watching this video. So why is it important when sampling? Because if we are deliberate, if we make deliberate choices, we will be biased, and we tend to systematically favor certain things. And we'll see that if I let you guys choose something, I'm like, just choose 10. That'll be your sample. You'll see that you'll overlook certain things. Okay. So when you get a table of random numbers, these show up. These can be in your textbook. There is a set of random numbers in the back of your textbook. There's a set of random numbers. I Googled this off the internet. Okay. Whenever you need to work your way through them, step one is you want to label your population. You want to label everyone in your population with a numerical value. Okay. If you have anywhere from 1 to 100 people, then you can fit them in 2-digit numbers, because you can have 00 be your first person all the way up to 99, and that's 100 different individuals. And then if each person is one of these numbers, then you start looking for 2-digit numbers. Okay, you use the table to select labels at random. If you have between 101 and 1,000 people, you would need 3-digit numbers to represent them, okay? Because there's 999 people when you go 001 through 999, and the 000 is the 1,000th person, okay? So depending on how many people you have, if you have between 1,001 and 10,000, you would need 4 digits so that everyone gets a unique label. Every individual gets a unique label, okay? So let's say we're in here. We're looking at 3-digit numbers. Well, then I would take the person 365 first, because those first 3 digits. And then I look at the next 3 digits. I would take the next person is 183. And then the next person is 677. But let's say I didn't use all of them. Let's say I had more than 100, but I didn't have all of 1,000. So let's say that I really only labeled them 000 through like 653. Well, then this isn't actually a person at 677. Neither is this 789 a person. Okay, but I would then take 116 and 055 and 422. 970 is not a person. You still count the digits, but you just cross it off and you say, yeah, that doesn't count as something. Okay. So you use the table to select labels at random. You need to identify, what would I do if I got to a repeat digit? We're unlikely, when we have 654 different people, to run into a repeat if I'm picking like 20 or 30 or however many people I'm trying to pick. But you want to say, what would I do if I got into a repeat? What do I do with numbers that are too big? Okay, you want to talk about how you select. These are the numbers that I'm using. What do I do with numbers that I'm not using? What do I do with repeats? Okay, and then you tell me, when should I stop? You stop when you have 30 unique individuals from the population. Okay, 30 unique numbers that were in my range. Okay, and then you need to go from the labels and say, select the subjects who had those numbers as their labels. Okay, and that's how you sort of now have a sample. So if I want to pick 30 random numbers that I throw out repeats. Then I stop once I get to 30 in distinct numbers that are between my min and my max that I set up, that I assign numerical values to. And then I take those 30 numbers and I say, oh, these are the 30 subjects. Okay. Typically, you don't actually list the subjects by name when you're describing this in a free response question. You just say, then you select your sample is the subjects who are associated with those numbers. And that quick sentence is sufficient. All right. In reality, if I want to select 30 people, what I would say is put the 643 names on pieces of paper in a hat. On a piece of paper, put it in a hat and mix. This is important because it assures what our goal is, which is randomness. Okay. Some people might say mix thoroughly. Okay. Pull out N papers. Now notice I'm accounting for the lack of repeats. I pull out a paper. Now they're in my selection. I don't put them back in the hat. Okay. So often you'll say without replacement. Don't replace them in the hat. Okay. And then those N people, it's already their names, are your sample. So this does the same thing as this, except for it's a way more efficient way to describe what you're doing. Instead of assigning everyone a label, you just put everyone's name on a piece of paper. Instead of using the table to select the random digits, you shuffle them up and you take out N names, and that's when you stop, once you've gotten out N names. And then instead of getting the labels back to the subjects, you just say, those names are my subjects. Okay. Both of those do exactly the same thing. So this is my preferred method because it's easier to write. And if I'm not physically putting a million names on pieces of paper in a hat, I don't mind writing the sentence, put a million names on pieces of paper, put them in a hat and mix them, pull out 50,000 names. I don't care. I'm not actually doing it. And so the quantities don't matter if it's just theoretical. All right. So random, I know, but good luck.